Good afternoon. Good afternoon.
Good afternoon, sir.
Is it audible?
Yes, sir.
Okay. Shall I start?
Yes, sir.
Uh, we have discussed about bar subjected to uniaxial stress, biaxial stress condition, and simple shear. In today's class, we'll talk about plane stress condition. But I will be not deriving all the expression regarding this. I will be just give. I have written myself. I will be discussing by using that. Okay. I'll go to that. This is roughly I've written it. So because since there is around 8 pages, you can see the PDF document is around 8 pages. Derivation is lengthy. It takes 3-4 classes. I thought of just discussing the same by using of my notes. Okay, it's one and the same. The principle remains the same. What we have discussed. First, we'll resolve the forces. Next, we'll find the normal stress and the tangential stress, and then we'll find the planes on which the maximum principal stress occurs. We'll substitute that into the normal stress equation. We'll find the magnitude of principal stresses, sigma 1, sigma 2. Next, we'll go to the tangential stress. We'll find the planes of maximum shear stress, and then we'll substitute that planes, that angles into that ft, and we'll obtain the magnitude of maximum shear stress. And then, since these planes are also accompanied with the average and with the normal stresses, we'll find the normal stresses. And then finally, we'll be plotting that. Okay, this is how it goes. First, I have taken a general case of general plane stress condition. This is a general plane stress condition. Plane stress in the sense, one of the direction there is no stress. There is no normal stress, or there is no shear stress. You can see along the z direction towards me and away from me. There is no normal stress or shear stress. So this is a general state of plane stress. Generally, this is plane stress condition. Sigma x, sigma x, sigma y, and my shear stress acting, it is causing anticlockwise rotation in the unexplained. This is positive sign convention for shear stress. Okay, this is my standard shear stress sign convention. Now, since I will take this, part BCE. I will take for the region BCE is where I am focusing. I am taking the region BCE. When I take the region BCE, I am left with forces sigma x, sigma y, tau yx, and tau tau xy, tau xy. These are the four forces I want to resolve. In the first problem, we resolved only one force f of 1. In the second problem, sigma x and sigma y, f of 1, f of 2. In the third problem, also f of 1, f of 2, but f of 2 was in different other direction. But there are four forces, then henceforth it becomes a little complicated. Okay, I'll write the four stresses, sigma x, sigma y, and then the normal stress perpendicular to the plane, tangential stress parallel to the plane, sigma t, sigma x, sigma y, tau, tau. I'll be writing like this. And then I'll replace this stresses by forces. Sigma x, instead of sigma x, I will be calling it as f of 1. Sigma y, I will call it as f of 2. And then tau, I will call it as f of 3. And this tau, yx, I will call it as f of 4. And f of n, f of 3 remains the same. If I resolve, I'll go to the first force. There is a F4. F4 is this force. You can see this is the F4. 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 If I resolve it, as usual, my theta is this perpendicular. Then it will become hypotenuse perpendicular to the opposite to the opposite to 90 degrees hypotenuse. Therefore, this is F4 cos theta, F4 sin theta. Similarly, if I resolve F1, F1 is also in the same direction. Instead of F4, you can write F1, F1 cos theta, F1 sin theta. Similarly, F3 and F4, F3, F3, and F3 and F2, F3 and F2, F3 you can see. F3 is in the y direction. If you want to resolve, you can resolve like this. F3 cos theta, F3 sin theta. Similarly, F2, F2, F2 cos theta, F2 sin theta. And then many three cases we have seen like that. So I'll be writing this force f of 1, sigma is equal to p by a or f by a. Sigma into a is equal to f. So sigma f of 1 is equal to sigma x into bc. F of 1 is equal to This is f of 1. F of 1 is equal to sigma x into BC. Similarly, f of 3 is equal to your tau into tau x into BC. Similarly, f of 2 is equal to sigma y into C. F of 4 is equal to tau xy into C. Similarly, normal force f of n is equal to sigma n into B. This is the plane B. And then f of t is equal to sigma t into B. This remains the same. Okay. Next. After resolving the forces, we know the summation of forces in the normal direction and tangential direction should be equal to 0. I will write my f of n force acting along the normal vector n, f of n directly, and then these forces f of n minus f, this is acting opposite to my normal vector. Normal vector is like this, is acting opposite, minus f4 cos theta, minus f1 cos theta, minus f4 cos theta, minus f1 cos theta. Ft is also acting opposite, minus Ft sin theta minus F2 sin theta is equal to 0. This is about a normal force. Similarly, tangential force, f of t, f of t, f of t minus, this is the tangential force, this is along the tangential force, f of t plus f of 4 sin theta plus f of 1 sin theta minus f3 cos theta minus f2 cos theta plus f of 4 sin theta plus f1 sin theta minus f3 cos theta minus f2 cos theta is equal to 0. Okay, I'll take the first expression when normal force is equal to 0, f of n is equal to 0. Instead of f of n, I will write this, I will take to the left hand side. F of n is equal to f4 cos theta, f1 cos theta, f3 sin theta is equal to f2 sin theta plus f2 sin theta. If I write f of n is given by sigma n into b, sigma n into b plus f4 f4 tau xy into c, tau xy into c cos theta plus sigma, you can understand tau xy in bc sin theta, sigma y c sin theta. And then if you take this to the denominator, sigma n is equal to tau xy c by b cos theta, bc by b cos theta. Like this, if you do, sigma n is equal to c by b, c by b is sin theta, c by b is sin theta, bc by b, bc by b is cos theta. So I'll be substituting here tau xy, c by b sin theta, bc by b cos theta, bc by b cos theta, c by b sin theta. Sin becomes sin square theta. Okay. Now I'll be writing two. There are two tau xy terms. This and this. This will become 2 tau xy sin theta plus sigma x cos square theta, sigma sin square theta. Cos square theta can be written as 1 half 1 plus cos square theta, half 1 minus cos square theta. If I club the terms, sigma n is equal to sigma x plus sigma y by 2 plus yes, sigma n. Ah, sigma n is equal to sigma x plus sigma y by 2 plus sigma x cos 2 theta by 2 minus sigma y cos 2 theta by 2 plus tau x sin 2 theta. So this is sigma n, sigma x plus y by 2, sigma y cos 2 minus sigma y. Okay. Straight I multiplied by sigma x, all this term. If I take common, sigma x plus sigma y by 2 plus sigma x plus sigma y by 2 cos theta plus tau x sin 2 theta. I am left with these two terms. Okay. Now I will resolve the tangential force. Sorry, I will what I will take the terms for the tangential force f of t minus f force and theta. If I just substitute, if I do the substitution, I will be left with the term sigma t is equal to minus sigma x minus sigma y by 2 sin 2 theta plus tau x cos 2 theta. This is mere. I will be sending the notes. Same PDF. You can understand. Okay. Only the c by b sin theta becomes sin square theta, bc by b cos theta and sin theta. You can do by yourself. Okay. Now we have done this. I know the expression for sigma n given by cos 2 theta plus sin tau x plus sin 2 theta, sigma x plus sigma y by 2. So if I want to know whether the planes of which are the planes of maximum, if I say sigma is maximum, means the sigma is maximum and these are the planes of maximum principal stress and there are no shear stresses acting on these planes. So in order to find the planes on which there is only normal stresses, that is the planes of maximum normal stresses, we need to differentiate it once. If I differentiate it once and if I substitute it to 0, if I differentiate it twice, it obviously means that it's going to be negative. So once I will differentiate this, sigma x minus sigma by 2 minus 2 sin theta plus 2 tau x by cos 2 theta. If I substitute this, I will be left with the expression tan 2 theta is equal to 2 tau x by sigma x minus sigma y. This is my expression for this principal plane. I can write theta 1 p theta p1 is equal to of tan square 2xy by sigma x minus sigma y. Theta 1 theta p1 is equal to theta 2 will be at an angle of 90 plus theta 1. We have discussed that theta 1 and theta 2 are at an 90 degree apart. Theta 2 will be at an angle of 90 plus theta 1. So I got the principal plane. The first principal plane is theta 1 is equal to of tan square 2 tau xy by sigma x minus sigma y. Second principal plane is 90 degree apart, 90 plus theta 1. Okay. Now in this expression, if you see here, but sigma and I have tan theta expression, but it will be easy for us if I directly substitute for cos 2 theta and sin 2 theta. So this tan 2 theta, what I will do, tan 2 theta is given by 2 tau x by sigma y. I will replace this as 2 theta. Then this will be 2 tau xy. This will be sigma x minus sigma y. Then a square plus b square is equal to root of a square plus b square. This is Pythagoras theorem. Root of sigma x plus sigma y the whole square plus 2 tau the 4 tau square x square. It will be your hypotenuse. Okay. Now I have written. Now I can easily write sin 2 theta 1 is given by 2 tau xy by sigma x minus sigma y opposite by hypotenuse. Cos 2 theta adjacent by hypotenuse sigma x minus sigma y root sigma x minus sigma y the whole square plus 4 tau x square x square. Okay, I have done this, but we what we have discussed, the two principal plane. This is sin 2 theta 1, but there are two principal plane, theta p1 and theta p2. Theta p1 we came to know sin 2 theta p1, sin 2 cos 2 theta p1 are these terms. Okay, for theta 2 we can see that sin 2 theta is equal to sin 2 into 90 plus theta. Theta 2 is 90 degree apart from theta 1, 90 plus theta 1. If I substitute here, sin 2 into 90 plus theta 1, sin 190 plus 2 theta 1, sin of 180 plus theta, ASTC, sin is a negative here, the sin of 180 is negative, okay. So sin of 180 becomes minus sin 2 theta 1, sin of 180 plus theta is minus sin theta, therefore it will become minus sin 2 theta 1. So I know sin theta, sin 2 theta, sin 2 theta 1, so this will be minus sin 2 theta 1. Similarly, cos theta will also remain the same. Cos theta, the same thing holds good. Cos of 180 plus theta. This is the cos of 180 plus theta. Cos 2 theta is equal to cos 2 into 90 plus theta 1. Cos 180 plus 2 theta 1 is equal to minus cos 2 theta 1. ASTC tan this cos of this cos will be negative in the third quadrant. Therefore, this will be equal to, is also equal to minus cos 2 theta 1. If I replace the sin 2 theta 1, if I replace the sin 2 theta is equal to 2 tau x square root sigma x minus sigma y square plus 4 tau x square x y with a negative sign here, then it will be equal to sin 2 theta. Similarly, negative sign here, this will be equal to cos 2 theta. As we came to know, sin 2 theta is equal to minus of sin 2 theta 1. Similarly, cos 2 theta is equal to cos of minus of cos 2 theta 1. Okay, we can write like that. Now I got we came to know what is sin 2 theta 1 and cos 2 theta 1. I have written here sin 2 theta is equal to sin of 2 to sin of minus sin 90. Similarly, cos 2 theta is equal to minus cos of 2 theta 1. Okay, which is equal to minus of sigma x minus y root sigma x minus sigma y whole square plus 4 tau square x square. We came to know principal planes. We need to substitute this in now sigma n term. If I substitute the cos sin term, sin 2 theta 1 term and cos 2 theta 1 term in sigma n, sigma 1 will be given by substituting theta 1, theta p1 or theta 1 for sigma 1. That is this expression, sigma n expression, sigma n. If I substitute cos 2 theta and sin 2 theta here, then this will be sigma x plus sigma y2. This there is no negative sign here. Sigma x minus sigma y root sigma x square plus 2 tau square x square. If I simplify this, sigma x minus sigma x y the whole square, 2 terms this term, and plus 2 terms square x y by this. If I take root x, sigma x minus sigma 4 tau square common, then it will be sigma x minus sigma y square. I have to get 2 tau square x y here. Therefore, it should be 4 tau square x square. 2 by 4 by 2 is equal to 2 tau x square. I can write the root 2 by root 2 is nothing but root 2. Root sigma x minus y sigma y square plus 4 tau square x y. Root of sigma x minus y the whole square plus 4 tau x square into root of sigma x minus sigma y the whole square plus 4 tau x square. One root we can cancel out. Therefore, we'll be left with root sigma x minus sigma y square plus 4 tau x square y. So this is sigma 1. So what I did, I got the value of cos sin 2 theta 1 cos 2 theta 1. I substituted in this sigma n expression. Similarly, I know the value of sin 2 theta 2 and cos 2 theta 2. I will be substituting once again in my sigma n term cos 2 theta p2 sin 2 theta sin 2 p2. Okay, I will be substituting in this minus sigma minus of this and this will be minus of this. Since I substitute, I can take minus common throughout 1 by 2 root simplification remains the same. Only thing in sigma 1 and sigma 2, this is very important. To what your machine design, you'll be working on this. What is principal says sigma 1 is given by sigma 1 is equal to sigma x plus y by sigma y by 2 plus half root sigma x minus sigma y the whole square plus 4 tau x square xy. This is the maximum principal stress. The principal stress are the stress where the principal planes are the planes. On these planes, the shear stresses are zero and the normal stresses are maximum. So one of the maximum principal stress is the maximum principal stress is sigma 1, the minimum principal stress is sigma 2. Okay. So this we have written. Only thing that what is the difference from here to here is this plus sign here, there is minus sign here. And these are the planes on which this is acting. Cos 2 theta 2, sin 2 theta 2 and sin 2 theta. If you substitute this, it is nothing but theta 1 is equal to half tan inverse 2 tau xy minus sigma x minus sigma y, and theta 2 will be 90 degree apart from that, plus 90 degree. Okay. Now we have found a sigma 1, sigma 2, and we have found the planes. Now we need to move on to the our maximum shear stress. To find the planes of maximum shear stress, what I will do, I will take sigma t expression first. Since this is complicated, I cannot directly say when 2 theta is equal to 90 degree, this expression will turn out to be maximum. I can't say this 2 theta is 90 degree, this becomes 0. I cannot say directly. Then I will differentiate this one. So if I differentiate this one, and then it will sigma x minus sigma y by 2 to cancel cos 2 theta minus 2 tau to sin theta. Will be left with 2 tau tan. I'm writing it to tan 2 theta s minus sigma x minus sigma y tau 2 tau x y. So tan 2 theta s is equal to minus of sigma x minus sigma y by 2 tau x y. What is the inference? Inference is my my tan 2 theta is equal to 2 tau x by sigma xy. This is inverse of this. This is what is that? This is the inverse of this. That is 2 tau x by sigma xy. That is this is sigma x minus sigma by 2 tau xy. Therefore, I can write tan 2 theta s is equal to minus like that only 1 by tan 2 theta p. Or if I multiply tan 2 theta s into tan 2 theta p is equal to minus 1. So what is your inference when you get the tan 2 theta 1 into tan 2 theta is equal to minus 1? What does it mean? What does it mean? What does it mean? When what does it mean? When two lines are perpendicular to each other, then the slopes are equal to what?
1.
Minus 1.
1.
Minus
Minus
1.
1.
Minus 1. Then the slopes are equal to minus 1. This is tan 2 theta s into tan 2 theta p, which is equal to minus 1. Then that is, they are mutually perpendicular to each other. Okay. Now, this is a 2 theta s and 2 theta p. I can write they are mutually perpendicular to each other. Now, let us see. Let us take, I am talking about this expression tan 2 theta s into tan 2 theta p is equal to minus 1. I will take an example. But before that, let us see. Therefore, theta p and theta s are 45 degree apart. Keep it in your mind that theta s1 is equal to theta p1 plus or minus 45 degree. Theta p2 is equal to theta p1 plus 90 degree. Theta s1 is equal to theta p1 plus 45 degree. How I will tell you. Let us take theta p1 is equal to 10 degree. Theta p1 is equal to 10 degree. For example, I am taking. Then theta s1 from according to our convention, it is equal to theta p1 plus 45 degree. From this, assume this as a formula. Okay, for time being. Theta S1 is equal to theta P1 plus 45 degree. Therefore, this will be 55 degree. But according we know that tan 2 theta S1 into tan 2 theta P1 is equal to minus 1. So this will be 2 theta S1 will be 2 times 55 degrees 110, 2 times theta P1 will be 20 degree. Therefore, it means to say that they are perpendicular to each other. The difference between these two lines 110 degree and 20 degree is 90 degree. Therefore, this will be equal to minus 1. For this to be equal to minus 1, tan 2 theta S1 and tan 2 theta P1 is equal to minus 1. Theta S1 and theta P1 should be 45 degree apart, plus or minus 45 degree apart, which I will discuss when plus when minus will discuss later. But you should know that they are 45 degree apart. Have you understood this? Have you understood this? You see this.
Yes, sir.
I've taken theta plus 10 degree, and this has to be 55 degree according to the formula. For accordingly, two lines to be mutually perpendicular, the angle between them should be 90 degree. One is 110 degree, and the other is 20 degree. Once for it to be 90 degree apart, this should be equal to the minus 1. Therefore, it means to say that it is 45 degree apart. Theta S1 and theta P1 are 45 degree apart. Have you understood this? Right? Now, Now I came to know what is theta s. Theta s is given tan 2 theta s minus sigma x minus sigma y by 2 to xy. Similarly, but my sigma t expression consists of sine term and cosine term. It is better to express my this term sigma x minus sigma y in 2 to xy in terms of sine and cosine term, so that I can directly substitute in my sigma t to obtain the expression for sigma t. Here we have obtained the expression for maximum planes of maximum principal shear. We need to obtain the magnitude of maximum principal stress. This is magnitude of maximal shear stress. So the substituting sigma x minus sigma y, it is nothing up to theta s is here. This is my hypotenuse. 2 tau xy. This is my uh, adjacent. If I take square root, if I take square this according to Pythagoras theorem, ac square equal to ab square plus bc square. This is what I have left out. Okay. If I write sine 2 theta s1 is equal to the opposite by adjacent minus sigma x minus sigma by this cos 2 theta will be adjacent by hypotenuse this term. Okay. We know that similarly theta s2 is equal to theta s1 plus 90 degree. Always you should remember that theta theta p2 is equal to theta p1 plus 90 degree, or theta 2 is equal to theta 1 plus 91 and the same, and theta s1 is equal to theta s1 is equal to theta p1 plus 45 degree, and then theta s2 and theta s1 are 90 degree apart, similar to principal stress. Theta s2 is equal to theta s1 plus 90 degree. Okay. Theta s2 written as theta s1 plus 90 degree. Okay. Now, Now, if I write 2 theta s2 is equal to 2 theta s1 plus 180 degree, sine 2 theta s2 is equal to sine 2 into theta s1 plus 180 degree. Instead of theta s2, if I write theta s1 plus 90 degree, if I multiply it by 2 theta, it will be 2 theta s1 plus 180 degree. But sine of 180 plus theta is minus sine theta, which will be equal to, this is minus sigma x minus sigma y, which will become plus sigma x minus sigma y by root sigma x minus sigma y square plus 4 tau x square y. Similarly, cos 2 theta s2 is equal to cos of 2 theta s1 plus 180 degree, which is equal to cos of 180 plus theta minus cos theta minus cos 2 theta s1, which will be equal to minus 2 tau x by this term. Okay, so sigma x plus 4 tau x. If I substitute here to find the magnitude of maximum minimum shear stress, substitute theta s1 and theta s2 in sigma t. Similarly, we have substitute theta p1 and theta p2 in sigma n to obtain the maximum principal stress. So to obtain the maximum shear stress, we have to substitute theta s1 and theta s2. I'll substitute theta is equal to theta s1 in sigma t. I'll be getting this is theta s1 minus sigma x5 by 2 tau x these terms. Okay, minus sigma x minus sigma y by root sigma x minus sigma y square plus 4 tau x square plus 2 tau x5 by 2 tau x square root 0 sigma x minus sigma y square plus 4 tau x square. Okay, now Now, if I multiply this, this will be plus sigma x plus sigma y square plus 2 times to sigma x plus sigma y plus 4 tau square plus 2 tau square plus sigma s square plus 4 tau square. Take 1 by 2 root sigma s plus sigma y square plus 4 tau square y common. Then we will left with this term. Since okay, okay. Now if I cancel it out, for example, root 2 is equal to root can 2 we can write it as root 2 into root 2, and then I can cancel one of the root. I'll be left of root sigma x plus sigma y square plus 4 tau square x square. So what you can see from this is, since my sigma t term is positive, it means to say that it will rotate my S1 phase in anti-clockwise direction. This is positive tau. Positive tau in the sense my shear stress will be acting in anti-clockwise. This is rotating in anti-clockwise direction. This stress and this stress will rotate the body in anti-clockwise direction. I'm talking about S1 plane. Okay. Now, I will substitute theta as 2. Theta as 2 is nothing but negative sign minus sigma x, 2 sigma x minus sigma y, and minus 2 tau xy. In sigma t, I will be substituting that. Therefore, I will be getting this expression, and it will be similar to that. I will be left with minus sign. Okay, theta is 2. Therefore, I can call the one with the positive sign as the maximum and one with the negative sign as minimum. Okay. Now, I also told you that the planes of maximum shear stress is also accompanied with normal stresses. In order to find the normal stresses, what we have to do, we have to substitute the value of theta s1 and theta s2 in the sigma n expression, isn't it? I want the normal stress. So in order to find the normal stress, I want to substitute in normal stress expression only, where what we have to substitute theta s1 and theta s2, the planes of maximum shear stress. So I will be substituting theta s1, which is given by 2 minus sigma x minus sigma y root sigma x minus sigma plus 4 tau square plus 2 tau x, so this 2 tau x term. I substitute this. I substitute this. Okay. Minus of sigma x cosine to tail cos to tail. So I'll be getting sigma r is equal to sigma x plus sigma y 2. You can also substitute cos of that is cos 2 theta s2 and sin 2 theta s2, which is one and the same. You will be getting minus sign here. You'll be getting plus sign here. What you got here is sigma x minus sigma y by 2. 2 tau x square root sigma x minus sigma y square plus 4 tau x square plus tau x square minus sigma x minus sigma y by root sigma x plus sigma y square plus 4 tau x square. It is one and the same. You can cancel it. This is plus. This is nothing but okay. This 2 cancels out. Therefore, it is sigma x plus sigma tau x square by this term minus of sigma x plus sigma x tau x square by this term. This will cancel out. Whether you substitute theta s1 or theta s2, you will get sigma average is equal to sigma x plus sigma y by 2 only. Okay, hope you understood this. Finally, we need to represent this sigma 1. It is acting at some angle theta p1. I don't know the angle. I will just write theta p1. Sigma 1 is positive or negative, which we don't know. I'll represent. In this case, we got positive. Sigma 1 acting away from the body. Plane p1 is at an angle of theta p1. Plane p2 will be 90. This is 90. This is 90 plus theta p1 will be the plane p2. Okay. And then this is plane p2, sigma 2 is represented. Similarly, shear stresses theta s1 anti-clockwise direction is positive. This is s1 is rotated like this. This is positive. Okay, sigma average. Sorry, and then I told you sigma tangential or tau, and that is rotating s1 plane in the anti-clockwise direction. This have written the magnitude. The anti-s1 plane is in the downward direction. Therefore, it will upward. Similarly, this direction, and it is also accompanied with average stress. Sigma average is given by sigma x plus sigma y by 2. Okay, this is about your plane stress condition. Okay, have you understood this? I will be sharing the notes. Once you glance, I have derived for 3 conditions, right? So it should not be difficult for you. Even though it is lengthy, the procedure remains the same. I have derived everything step by step. Have a look at that. Okay, right? Have you understood? Hello?
Yes, sir.
Is there any doubts? You go through this once. It looks lengthy. You might be seeing many things here, but go through that once. It is like procedural only. We are started from scratch. We have obtained f of and f of t. We have obtained our principal planes. We have substituted the principal planes in the principal the sigma and equation to find the magnitude of sigma 1, sigma p1 and sigma p2, and we came to maximum shear stress. We have obtained the planes of maximum shear stress. We have substituted the planes of maximum shear, that is the angle to the sigma t equation, and we obtain the magnitude of maximum shear stress. And this maximum shear stress is also accompanied by average stresses that can be founded out by at what angle there is a maximum shear stress angle, is there any average normal stress. We have substituted theta s1 and theta s2 to our sigma n. So in order to find sigma n, finally we have represented written a sketch of that. That's it. Okay. Next class I will give you the theory part. Don't miss the next class. I will be giving the theory part of the procedure how to solve the problem. It is very easy and very important. Theoretically, how to solve the problem. Graphically, we will discuss in the next class. Okay. Theoretically, how to solve the problem discuss. And I will give the procedure one next class. I will give. Uh, Time being, I will be sharing these notes in Google Classroom. Have a look at this. Okay. I will stop at this point.